So do you guys know what is inertia? Inertia? What is inertia? Do you guys know about that? See, inertia is the inherent property of the body due to which it resists any kind of change. Any kind of change I'm saying. Okay. If there is change in motion or state of motion, then it will resist. If there is change in direction, then it will resist. If there is change in rest, also it will resist. So it is inherent property of the body. That means it is in the body. So this is called inherent property of the body due to which it resists any kind of change in it. It is called inertia. Got it? What is inertia? Yeah, whosoever, Likhit. Likhit, got the point? What is inertia? The property of the body due to which it resists any kind of change in it. It is
Yes,
called
ma'am.
inertia. Okay. So now we have also studied about the types of inertia. So there are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Okay. Likhit,
Yes,
since
ma'am.
you have not attended the previous class, so you have to take a screenshot of
Ma'am,
this
your
slide.
voice is breaking.
Hello, am I audible?
Yes, ma'am.
Yeah, okay. So Likhit, as you told that you have not attended the previous session of this chapter, so you have to take a screenshot of this
Ma'am,
class.
just a
Okay,
minute, ma'am.
okay,
I
okay,
think I have some network issue.
okay. Can you rejoin, Likhit?
Yeah, ma'am. Yeah,
Okay.
ma'am.
Is it same with others also? Nived, Harinia, Niharika, Sugandha, am I audible? Am I audible properly? Okay, okay. Thank you so much, Sugandha, for confirming. Okay, Niharika, thank you so much. Okay, Harinia. Yes. So whosoever guys have not attended the previous session of this chapter, you guys can take a screenshot or can take photo of this slide. Okay. So this is the type of inertia. What is inertia? The inherent property of the body due to which it resists any kind of change in its motion, its rest, or its direction is called inertia. This is of three types: inertia of rest, inertia of motion, and inertia of direction. That's it.
Hello, ma'am.
Yeah. Yeah, Likhit, have you taken the screenshot?
Ma'am, I will take 1 minute.
Okay, take it fast. Done?
Ma'am, just a minute.
Okay. Now, someone tell me about the acceleration. What is acceleration? What is the proper definition of acceleration? Anyone can tell. Anyone? Don't you guys know about the acceleration?
Yes, ma'am. Done. Ma'am, acceleration
Check.
is rate of change of velocity.
Correct. Rate of change of velocity. Which kind of quantity this is? That means whether it is vector quantity or scalar quantity?
Ma'am, it is vector quantity, I think.
Exactly. It is a vector quantity. Now tell me about the SI unit. What is the SI unit of acceleration?
Meter per second.
No, not at all.
Ma'am, meter per second square.
Exactly, meter per second square. Okay, acceleration is the rate of change of velocity. It is a vector quantity, and the SI unit of acceleration is meter per second square. Yes, so we have completed our topic with inertia. So what is inertia? The mass of an object. Okay, one more thing is there. First of all, we have understood about the inertia, that any kind of the property of the body due to which it resists any kind of change in it is called inertia. Now, this is the measurement of mass of the body. That means it is directly proportional to mass. If the mass will be more, if the mass of the body will be more, then inertia will be more. And if the mass of the body will be less, then inertia will be less. That means we can say inertia is directly proportional to mass. Just a second. Inertia, I'm writing. Inertia is directly proportional to mass. So we can say mass of the body is measure of inertia. Whosoever body will have higher mass, that will have higher inertia also. Okay. Now tell me, there is a tennis ball and there is a cricket ball. That means leather ball. Whose inertia will be more? Tell me fast. Whose inertia will be more?
Ma'am, can you please repeat the question?
Yeah, there is two kinds of ball, one tennis ball and one cricket ball. Whose inertia will be more?
Ma'am, cricket ball.
Exactly, cricket ball. Why have you given answer cricket ball?
Ma'am, because most of the cricket balls are leather balls, so they have a greater mass than tennis
Exactly.
balls.
Exactly. That means inertia is directly proportional to the mass. If the mass will be more, inertia will be more. That's it. Got it? Got the concept of inertia? Is there any problem in inertia and types of inertia?
No, ma'am.
Okay. Then we have done the second topic in the previous classes, that was momentum. Okay, now let's see what is momentum. So it is the product of mass and velocity of the body. The product of mass and velocity of the body, it's called momentum. It is represented by small p. Got it? It is small p, not capital P. Now tell me, by which quantity we represent capital P? Capital P in physics. In physics, I'm asking.
Ma'am, capital.
Capital P. Tell me fast. It is power only. Okay,
Ma'am, power.
exactly, power. Yeah, so momentum will be represented by the letter small p. Okay, it is a vector quantity. Got it? Now tell me what will be the SI unit. One more thing is there. P equals to mv. This is the expression for momentum. That means, as I have told, that momentum will be the product of mass and velocity of the body. Two things will be there, mass and velocity. So product of that will be called momentum. Got it? So we can represent, as I have told, we can represent the momentum by small p. So as P will be equals to mv. Now can you guys tell me what will be the SI unit of this? What is the SI unit of mass? What is the SI unit of mass?
Ma'am, kg.
Kg, exactly. It's very easy. Now, what is the SI unit of velocity?
Ma'am, meter per second.
Exactly, meter per second. So, the SI unit of momentum will be kg meter per second. That's it. Got it? So, what is momentum? Product of mass and velocity of the body will be called momentum. Got it? Then, it is represented by small p. Which kind of quantity will be it?
Ma'am, it is a vector quantity.
Exactly. It will be a vector quantity. Okay. So product of mass and velocity of the body will be called momentum. It is represented by small p. It is a vector quantity. The expression will be given by p equals to mv, and the SI unit will be kg meter per second. That's it about momentum. Is it clear? Is it clear about momentum?
Yes,
Niharika,
ma'am.
Ryan, more weight, cricket ball, exactly, kg meter per second. Niharika. Okay. Now, Likit, you can take a screenshot of the slide. जिन्होंने भी प्रीवियस क्लास नहीं किया था, आप लोग इसका स्क्रीनशॉट ले सकते हो. Whoever not attended the previous class, you can take a screenshot of this. Done. Shall I move to the next slide?
Yes, ma'am.
Okay. So this was the second concept which we had done in the previous classes. Now, this is the question given. In the given figure, the arrows indicate the direction of forces F1 and F2. First of all, tell me which kind of quantity force is, whether it is a scalar quantity or vector quantity? Force. Tell me fast. Very easy. Vector quantity. Okay. Just a second. Let me check in the class forum. Ryan has given answer C. Sugandha has given answer C. Okay, let me dictate the question first. In the given figure, the arrow indicates the direction of forces F1 and F2, and the magnitude of the respective forces are given above the arrows. Initially, the block is at rest. In which direction will the block move? F1 is given 6 Newton, F2 is given 5.5 Newton. Okay. Niharika, Sugandha, Ryan, all are giving answer C. Let me check what will be the answer of this question. See, as we know that force is a vector quantity, so it depends on direction. Okay, so F1 force has been applying in this direction and F2 force has been applying in this direction. That means this one is from right to left and F1 is from left to right. Okay, so what can be F net? How can we calculate that? So it will be greater force minus smaller force, F1 minus F2. So it will be 6 Newton minus 5.5 Newton. So it will be 0.5 Newton. Got it? So which force is larger? F1 is larger. That means left to right direction force is larger. So in which direction the block will move? So the block will move toward the direction of force F2. Why you guys are giving answer C? The block will move towards the direction of the force F2. 5.5 is 5.5 Newton is the less force than the 6 Newton. Then which direction it will move?
Ma'am, it will move in the direction of F1 because
F1
the
force
force
is,
is larger.
yeah, amount of force given in F1 is larger. That's why. Right? C. This is the correct answer. Why you guys are giving answer C? Any doubt in this question? Very easy question was that. Do you guys know the concept of net force? Net force or balanced force, do you guys know? Balance and unbalanced force, do you guys know about that? Okay, I thought C was going right. Okay, Ryan, no problem. Now the answer is clear to you or not? The block will move in the direction of force F1 because F1 has given magnitude 6 Newton and F2 has been given magnitude 5.5 Newton. That means F1 has more amount of force. So the block will move in the direction of F1 force, not in F2 force. Got it? Is that clear now? अगर किसी को डाउट हो then you can ask. Now, this question has been given. Which of the following will have the greatest value of momentum amongst them? Okay, so this question has been asked about momentum. What formula I have told about momentum? P equals to, tell me fast. P equals to, small p equals to,
MV, mass into velocity.
exactly, mv, mass into velocity. Exactly, Niharika. Very good. Now calculate momentum in all the cases. That means A, B, C, D. Calculate it fast. Rian has given answer B. Just a second. Hello, am I audible?
Yes, ma'am.
Okay. Rian has given answer B. Okay, Rian, have you calculated that? So fast you are. Okay. There are 11 participants, so I want 11 answer in the class forum. Give your answer fast in the class forum about momentum. Which body will have the highest amount of momentum? Niharika also give an answer B. Okay, Niharika, let me check. Tushar also B. Okay. All are giving answer B. Very nice. Suhana also given answer B. Sugandha also B. सभी के आंसर्स बी आ रहे हैं, मतलब बी में कुछ तो है. Now tell me about C only. What will be the momentum of the body C? An idle rock of mass 3 kg. What will be the momentum of that rock? Ryan has written 0. 0 or O? What you have written, Ryan? Is it 0? Right? Yeah, that will be 0. Exactly. Okay, don't you have to do anything? You just have to multiply mass by its velocity. Okay, so in the first case, we are given mass 600 grams. So first of all, that you have to calculate into kg. So 600 gram will be equals to 600 divided by 1000 kg. So you can convert easily, and then you will multiply that kg amount by the 18 meter per second. After that, we will be able to calculate momentum of that body. Then in B also you have to do the same thing. 15 kg mass is given, 0.8 meter per second the velocity is given. You have to calculate that. Then in C we have just calculated that the momentum of this body will be 0, and D you can calculate by the same process. D Ryan is asked. Ryan, is that any question? D equals to 7.5 P. Okay, you have given answer of the D, right? That means you are telling about the momentum of body D, I think. Okay, Ryan. Yeah, that is correct. So B is the correct answer of this question. Very good. Whoever calculate the answer B, that it's correct. Momentum will be equals to mass into velocity. So mass is given 15 kg, velocity is given 0.8 meter per second. So I think you have calculated it 12 kg meter
Mom,
per
can
second.
you put it down, mom?
Yes, yes,
Like
yes.
C and D. Can I see C and D values, mom?
C and D. Yes.
Values there,
And
mom.
yeah, in C, you can see here that the rock has been at rest. So in that case, the velocity will be 0. So the momentum will come also 0. 3 kg into 0. So that will be 0. In D, it is given 1.5 meter per second, and mass has been given 5 kg. So in that case also, you can calculate the momentum by multiplying 1.5 by 5. Yes, Rian. So have you guys done it? Shall I move to the next slide?
Yes, mom.
Okay. So B was the correct answer of this question as you have calculated. So today we have to discuss some more topics in this chapter, which is Newton's second law of motion. But before going to the Newton's second law of motion, first of all, tell me what is Newton's first law of motion? And let me tell you, this law is also called, not I'm not talking about the second law of motion, I'm talking about the first law of motion. So first law of motion is also called law of inertia. Okay, inertia we have just done. Okay, so what is law of inertia, or what is Newton's first law of motion? Can anyone tell the statement of Newton about first law of motion? Anyone? कोई भी बताओ.
Ma'am, is it the law of inertia?
Yes.
Ma'am, Newton's first law is if the body is in motion, it likes to be in motion. I don't know the exact definition, but if a body is in motion, it would like to be in motion. If a body is at rest, it would like to be at rest. It would be at rest until an external force applied on it.
Exactly. Very good, Likhit. Correct. Correct definition. That means a body continues to be in a state of rest or in uniform motion until and unless two things are there. Until and unless there is no net external force acts on the body. So this is called Newton's law of that means law of inertia also. Newton's first law of motion is also called law of inertia because the statements are likewise. Got it? Any body continues to be in a state of rest or in uniform motion until and unless there is no net external force acts on the body. That is the statement of Newton's first law of motion. Got it? Which is also called law of inertia. Okay. Now, in starting the session, I have asked about the acceleration, right? So you guys told that acceleration is nothing but rate of change of velocity. Okay. So first of all, tell me if the initial velocity, not in an initial, if a body suddenly stops, okay, then which velocity will be zero? Whether it will be initial velocity or final velocity.
Ma'am, final velocity.
Exactly, final velocity. That means you guys have learned in motion. Yes, Niharika, that will be final velocity. Now, if a body start from rest, then which velocity will be zero?
Initial velocity.
Exactly, initial velocity. Very nice, very good. You guys are clear with your concept. Niryan is talk initial. Niharika also given an answer initial. You guys are clear with your concept of motion. Very nice. Now tell me, slope of distance time graph gives fast. Tell me fast. Slope of distance time graph gives. Let me check in the class forum. Very good. Slope of velocity time graph gives.
Ma'am, the change of velocity.
No, slope of VT graph. Slope of VT graph.
Ma'am, actually, I forgot, ma'am.
Acceleration only. Slope of VT graph gives acceleration only. Okay.
Okay.
Slope of displacement time graph gives velocity. Slope of velocity time graph gives acceleration. Okay. Area under AT graph, that means area under acceleration time graph gives. Tell me fast. Area under AT graph gives
Velocity.
change in velocity. Okay.
Yeah.
There is correctness in that. Change in velocity. Now area under VT graph gives. These concepts are very important for your class. Okay. इसको अच्छे से करना ही होगा आप लोगों को. You don't have any other option. Area under VT graph gives. Exactly. Very good, Ryan. Very good, Niharika. That will be displacement. Very nice. So you guys have to learn the concept of area under graph and that slope of the graph. Okay. Yeah. Newton's second law of motion we are talking about. Do you guys know how seat belt of the car or the vehicle works? Do you guys know about that? Seat belt. Okay. There is a derivation in Newton's second law of motion. So we will do that. But before that, let's talk about some concepts of Newton's second law of motion. So the question has been asked, how does Newton's second law help in doing so? How does Newton's second law of motion help in saving lives with a seat belt? Okay, this question has been asked. So do you guys know about that? Watch the video first. Then you will be able to give answer of this question.
So what does this momentum really tell us? Why do we have this momentum? Because if you notice, with this quantity of called momentum, we can start defining our force in a much more specific manner than we've done before, which is a push or a pull. That's a pretty vague definition, right? So the way we do this is what's going to bring us to Newton's second law. And that says the rate of change of momentum is equal to the force applied. To be more precise,
Write down this definition of Newton's second law of motion. Do it fast. See, whenever you will write about the laws of motion, then you have to start with that statement. It states that, okay, it states that. After that you will start inverted comma, as you can see in the slide. Okay, you will start inverted comma, and within the inverted comma you have to write the definition. Okay, so how you can write the definition? You have to write it states that. That means Newton's second law of motion states that the rate of change of momentum is equal to the net external force applied. Newton's second law of motion states that, inverted comma start, the rate of change of momentum is equal to the net external force applied. It states that the rate of change of momentum is equal to the net external force applied. If done, you guys can give thumbs up in the class forum, or you can type done. Okay, Niharika. What about others? Do it fast. Newton's second law of motion states that the rate of change of momentum is equal to the net external force applied. Sugandha also done. Very good. What about others? Nived, Harinia, Suhana, Anshika, Rayan, Tushar, Akul. Give your answer fast in the class forum. You have done or not? Have you guys done it? Tushar has done, Harinia has done, Suhana has done. Akul, Likith, have you guys done?
Ma'am, I can't see the slide, ma'am.
Actually, this is not a slide. This is a video slide.
Okay.
Is that visible?
Yeah, ma'am.
Okay.
Yes, ma'am.
You just have to note down the definition of second law. Okay.
Okay. Just a minute.
After that, you have to type thumbs up in the class forum. Okay, Shashiti will. Okay, Suhana. Newton's second law of motion states that. After that, you will have to start inverted comma, and within inverted comma, you have to write down the rate of change of momentum is equal to the net external force applied. डन सभी का हो गया
Done, ma'am.
again was
the net external force applied. So the rate of change of momentum, let's call momentum P. You might ask, why don't we call it M? Why don't we call it M? Because it is already taken. By whom? By mass. Yeah, mass. We kind of figured out about mass before, momentum. So it's already taken up. So we have mass. So therefore we call momentum P. And delta P kind of tells you the rate of change of momentum. So delta P by delta T is going to be rate of change of momentum. And you have force on the other side. So F equals delta P by delta T is going to give you Newton's second law. Great. So what is the exact implication of this? This is the most general form. You can write it this way. But usually an object's mass, if it does not change, unless it's a rocket that's flying off into space, ejecting a lot of gas, then the mass changes. But otherwise, the mass does not change. Then you can kind of assume the mass to be a constant. So you'll write delta P as what? if the final mass is still m and the first mass is also m, then you'll have mv1 and mv2. So what will be the change of momentum, delta p? It will be mv2 minus mv1, and because it's a rate, it's divided by time, so divided by delta t. And you can clearly see that the mass can be taken out. And what do you do after that? You have m v2 minus v1 by t. And from your previous chapter, you know that v2 minus v1 by t is the change of velocity, the rate of change of velocity. Therefore, that's equal to the acceleration. So in the special case where the mass of the body is not changing, F equals b by delta t becomes Newton's second law in its most commonly known form, F equals ma. So that one equation there is probably the most important equation of mechanics that you'll ever learn, because you'll use it everywhere. It is all of F equals ma. So that,
note it down fast. Okay, this is the derivation of Newton's second law of motion. In this derivation, what we have supposed that a body is having initial velocity v1, okay, and the final velocity v2. Then what will be the initial momentum? It will be mv1, right? And what will be the final momentum? It will be mv2. So how can we calculate the change of momentum? That means the final momentum minus initial momentum. So this is nothing but mv2 minus mv1, right? And divided by delta t, as we have just studied about the second law of motion, that net force applying on a body will be equals to rate of change of momentum. Okay, so this will be mv2 minus mv1 divided by delta t. Okay, m we have taken common because it is constant, so it will be v2 minus v1 divided by delta t, and that rate of change of velocity gives acceleration, so we can write that F equals to ma. That's it. Delta t is change in time, ma'am. No, delta is change in momentum. Delta p, that is given delta p by delta t. That means rate of change of momentum. Okay. Whenever something changes with respect to time, that is called rate. Okay. So delta represent change. So delta p represent change in momentum and delta t represent change in time. Is that clear, Likhit? Delta p is change in momentum and delta t is change in time. Is that clear, Likhit? If you guys have noted, you can give thumbs up in the class forum or you can type done. Okay, Likhit. Okay, Niharika. Okay, Ryan. One more thing I wanted to ask from you guys, that it is showing out of 15 class you have attended 14, out of 15 class you have attended 12, but in actual 43 or 44 class has been conducted till now. Okay, so why you guys are so late? Nived, anyone, Nived and Harinia, you guys have full attendance. So can you guys tell me why this is? Nived?
Ma'am, I actually don't know. I just take every class.
Okay.
Sometimes, yeah.
Till now 43 classes has been conducted, but it is showing that out of 15 classes you have joined 14. Then why this done?
Ma'am,
Okay.
because 15 classes are probably for science like that.
Okay. Okay. Then got it. Okay, लिखित. Okay, सुहाना. तुषार also done. रियान तो पहले ही टाइप कर चुका था. Okay. So सभी का हो गया ना? Have you guys done it?
That one equation there is probably the most important equation of mechanics that you'll ever learn, because you'll use it everywhere. It is all abiding. It's going to make it so that every single problem becomes solvable in a very simple manner. Now, when you look at that, what do you notice? What is that equation trying to tell you? For a given force, the larger and larger and larger the mass, the lesser and lesser and lesser the acceleration. And what is the acceleration a measure of? How much is the velocity going to change? Kind of makes sense, right? You kick a very heavy ball, its velocity is not going to change much. Kick a very light ball, it goes pretty far, right? But what does it tell you? It tells you that no matter how far and close something is going, if you multiply their mass and velocity, it's going to be same, as long as you kick with the same force. So this F equals ma is going to give you an intuition about how mass and acceleration are related. Now, why is this important? Because till now we spoke about inertia as a separate concept. What is inertia? The tendency of a body to maintain its state. The tendency of a body to kind of resist a change to its state of motion. And here we see something, right? What is this mass really telling you? The more and more the mass, the lesser and lesser the acceleration. In other words, the more and more the mass, the more and more its resistance to motion.
Got it. So this only we have seen in the second law of motion, that the net force acting on a body will be equal to rate of change of momentum. Okay. That means whenever we will have to find out the net force, what we are supposed to do there, we just have to know about the momentum. We just have to know about the time. Okay. So whenever we have these two quantities, we can find out the net force. Okay. Also, we can calculate the net force by multiplying mass into acceleration. If the acceleration will be more, then mass will be less, and if the mass will be more, then that body will have less acceleration. Okay, so these kind of relation will be followed in mass and acceleration concept, okay, for making the force. Now one more thing is there, just a second, let me take the pencil first. As you can see here, can you tell how force, net force, and the time are related? Is that directly proportional or inversely proportional? Tell me fast. How net force and time are related? Is that direct relation or inverse relation? Tell me in the class forum fast. Is that direct relation or inverse relation? जल्दी से बताओ, कोई भी बताओ. Which kind of relation is that? Direct or inverse? The relation between force net and delta t, that means change in time. Is that direct relation or inverse relation? Don't you guys know about that? Yes. निवेद, हरिनिया, निहारिका, सुहाना, रेयान, तुषार, लिखित, दिशा. कोई भी बताओ मुझे, which kind of relation is that between F net and delta t? Yeah, I have enabled that, Likhit.
Yes, ma'am. Yes, ma'am. I think it's directly proportional.
No, not at all. It is inversely proportional. Okay. Let me show you. See, I'm so sorry. I'm not able to write here now. I'm going to the blank slide. F net, we have just studied delta P divided by delta T. Okay, so this is inverse relation between F net and delta T, that means change in time, and there is direct relation between delta P and F net. Got it? This one is numerator, this one is numerator. So whenever delta P will increase, F net will increase, and whenever delta P will decrease, F net will decrease. But the relation between F net and delta T is like that: if the time will increase, F net will decrease, and if the time will decrease, F net will increase. This kind of relation is called inverse relation. Got it? Got the concept? Is that clear? Yes, indirect, Suhana. Correct. Yes, Niharika, it is inverse. Okay, so if time will increase, F net will decrease, and if time will decrease, F net will increase. That is the relation between F net and time. Okay, that is called inverse or indirect relation. So we will have some application based on that. This we have done. Yeah. Now let's do the application of this. The seat belt of the car gradually brings the driver to rest. Just a second. See, the seat belt of the car gradually brings the driver to rest. Okay, so whenever time will increase, how force changes? Force will decrease. Okay, that means जो हमारा momentum, whenever the time will increase, the momentum which is coming to rest not suddenly decreases, it decreases gradually. That means वो धीरे धीरे decrease होता है. ठीक है, जिस वजह से due to which our force get decreases very slowly. Okay, and it comes to zero after some time, not suddenly. That's why we feel the jerk less, or we feel the hurt less. Got it? Is that clear? That means if the time will increase, f net will decrease. This is the concept here. That is the working of seat belt. Okay, that just increases the time, just increases the time of stopping the body. Okay, so for stopping the body, that time has been taken to reduce the force. That's the concept. Is it clear? Now let's do some other application also, then you will be able to do that. Yeah, this is the question. A constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of applied force. This is very easy question, I think. You guys will be able to do this. First, you have to try. After that, I will make you understand about this. This is the question. This is the data. Do it fast and give answer in the class forum. जल्दी से करो इसको. Do this question fast. Mass is given, change in velocity is given, time is given. You just have to calculate acceleration and you just have to multiply mass by acceleration. You will get force acting here. Niharika is saying 10 Newton. Ryan also 10 Newton. Okay. Let me check. What about others? Have you guys done it? Likhit also 10 Newton. Okay. Now let me solve this question for you guys. A constant force acts on an object of mass 5 kg. So mass has been given 5 kg. And acceleration is not given, but change in velocity is given, that the velocity has been changing 3 meter per second to 7 meter per second. Okay, so can we calculate acceleration as change in velocity v minus u divided by t? We can calculate it as 7 minus 3 divided by t. What is given? 2. So it will come out 4, I think. 7 minus 3, 4. Yeah, divided by 2. So it will 2 meter per second square. So we can calculate force here. Force equals to mass into acceleration. Mass we are given 5. Acceleration we have calculated 2. So it will be 10 Newton. Answer. Got it? So 10 Newton is the correct answer. Very good. Okay, just a second, Likhit. Yes, Likhit. Likhit.
Yes.
I have,
Yeah,
yeah,
ma'am.
I have enabled that.
Yeah,
Yes.
ma'am. Okay.
Is that clear? सभी को ये question clear है ना? निवेद, हरिणिया, निहारिका, रेयान, तुषार, लिखित. Is that clear?
Yes, ma'am.
Okay. So 10 Newton was the correct answer of this question. Again, there is question, and let me tell you, this question is combination of the concept of motion and force and laws of motion. Okay, so do this. I'm again disabling the mic. After solving the question, I will enable that. Okay, Ryan, do this question fast. A person fires a 30-gram bullet towards the target in a shooting range with a velocity of 30 meter per second. The bullet embeds into the target up to a depth of 10 centimeter before coming to a stop. What will be the magnitude of the force on the bullet? That is the question.